First of all, I know it must be a cliche, but I have to say how happy I am to be here attending the GRCon after being using GNU Radio for so many years, since I was like doing bachelor's. And today I'm going to talk to you about a little bit about what we're doing using GNU Radio to do experiments in the millimeter wave range, more specifically in the initial access. If not familiar with all this millimeter wave jargon, don't worry, I'm going to walk through all of this during the presentation. My name is Joao Santos. I'm a postdoctoral researcher with the Commonwealth Cyber Initiative. We are a research institute associated with Virginia Tech and in Northern Virginia, just across the Potomac. Here you go. In a nutshell, what we did with this work, right, was to enable to expose the control over different millimeter wave frontends in GNU Radio that use the GPIO interface, allowing them to be controlled on the fly inside of your flow graphs. Beyond that, once you're able to control the radios in the millimeter wave, we also did a complete initial access control loop, allowing them to do two different frontends to be able to locate each other and find the best beam direction to communicate. With that, right, we enable a bunch of different high-level experiments where you can play around, you can point your beams to different regions, to different points of time, and you can also test around design trade-offs in your initial access procedure, tailoring that to suit your needs. First of all, why should you care, right? We're going to go a little bit about our motivation, then our implementation in GNU Radio. So also show you some of our experimental results and finishing with the current state of this contribution. First of all, you're happy doing your experiments in GNU Radio, right, in the below 6 gigahertz band. You create your DSP chains, place your blocks, and everything works most of the time. Until like you start playing around, move your radios a little bit to the side. If you put them like 2 feet further away from each other, then it would work. You start playing around with the gain to make sure they're happy, and then you increase the gain too much, and then you saturate the receiver. But alas, no, it's still great for broadcast experiments, and it works great. But let's say you're bored or you want to explore the millimeter wave band, right? You want to break this directional communications barrier. What do? It's very likely that you're going to end up hooking up your current setup and your current CRs and your code base to millimeter wave frontend, which is an equipment that up-converts and down-converts your signals that outputted from your SDRs now become like any intermediate frequency, and you bring it up to the millimeter wave range. This kind of equipment usually also possesses a patch antenna array with a bunch of different elements and allows you to change and play around the code books so that you can point your signal to different directions. It's amazing and it works. And it's great for characterizing the environment, the equipment. Some people even do this for creating some sort of radar equipment, even inside of GNU Radio, and it's wonderful. But as you start playing around with this, you soon realize, okay, if I move my radios around, not only have to worry about the gain and whatnot, but now the direction that I point my signal is also important. So you need to steer your beams from both the transmitter and receiver so they can find each other. But as of now, we really only have like manual ways of doing that over this GPIO-based millimeter wave frontends, right? So that you generally have to, out of band, outside of GNU Radio flow graph, you have to manually say, yo, please move there, please move here. But okay. However, these may not be practical in some scenarios. Let's say if you are moving around, if you're a car or on a robot or if you're a handheld device, these will not cut the chase, especially if you have multiple users going to different directions. You can't really do this in real time manually. That's why commercial millimeter wave equipment and the mobile standards that operate in a millimeter wave range, they include what is called the initial access procedure, whereby both transmitter and receiver radios, they scan sweep to different distances and find each other, right? They keep transmitting information back and forth. They find the direction that works better for both of them, and they establish a handshake, and they finally start transmitting information over the beam of the highest, beam pair that has the highest SNR. It works great. But I think this is a kind of a Mac level handshaking procedure that I couldn't really find in GNU Radio. And you're like, okay, what to do next, right? You can kind of control the beans manually, but can you do more? Yes. So we started to delve deep into the millimeter wave frontends that were under possession, and realized that, okay, yes, they actually allow you to do this online runtime error configuration, usually using their commercial closed source frontends or controllers that are super expensive. But they allow you by hand to play around with the bean over their SPI or GPIO interface. Then you thought, okay, so the millimeter frontends, they have the GPIO control. The GNU Radio supports and allows you to play around with GPIO commands, and USRPs also have a great GPIO interface, if you remember the presentation I had from the NA guys on Monday. So we then connected the dots and created what we call Stamina, a software-defined millimeter wave initial access. Who doesn't love man-made acronyms? So with Stamina, we do two different things. First, we expose and abstract the control over the millimeter frontends over GPIO instead of GNU Radio, right? So that you only have to focus about the things you care for your millimeter wave experiments, the pins you're pointing, and so on and so forth. And we also closed the loop and created a complete initial access control loop, pun intended. So first, when we started to look into the GPIO interface and the different millimeter wave frontends, we soon realized, okay, so they basically use different pings and different ranges of pings to do the same things, right? Set a beam in ping 5 to different directions, whatever, transmitter, receiver. But the different pings in different places. So to do the same thing, we thought, well, can we parameterize that? Can we expose this in a way that users can use it and just tailor depending, with little modification, can use it with their own equipment? To do so, we created an abstracting block in GNU Radio that you can feed with information over how your particular millimeter wave frontend works using a configuration file. And then you're free to go. In addition, it allows us to reconfigure the pins you're pointing for transmitter and receiver at runtime using asynchronous messages. And then, great, with this, you can basically start controlling your millimeter wave frontends within GNU Radio. Great, but we were not happy there, right? We wanted to go a few steps after that. So we created the whole control loop structure, where at the same time we sweep over different pings, right, for transmitter and receiver, while we collect all this information in terms of the received signal strength and label that with the current pings for transmitter and receiver. And based on the highest value, we decide, okay, let's use that given ping pair for communication. And we look so that we can adapt to changes over time. Here, a little bit about our realization in GNU Radio. On the top and bottom, you can see our WFM transmitter and receiver. And the center, we have the blocks for control, measurements, and decision, right? I think despite being a rat's nest of control messages being exchanged across different blocks, it's working great. And we also leverage the beauty and the versatility of GNU Radio that allows us to play and change with those parameter variables during runtime. So with this, we can, almost there. Okay, there's much time left, I have to sprint. But then again, with this, we can like reconfigure and arrange how this works in terms of the pings we sweep, how long we stay there, so on and so forth. Here, a picture to illustrate our very messy deployment with both millimeter wave frontends, and in the center we have our host machine with running GNU Radio, our out-of-tree block, and USRP, and the millimeter wave controller unit that has the GPIO interface. Skip this. And here, finally, we go to like some of the results we got, right? So we start exploring how systems behave. So first we want to validate whether everything was working. So we set up the two radios pointing at each other, started playing around with the tilt and the orientation, and start to identify how we obtain higher power from different directions, and also be able to observe the benefits of running an initial access procedure over doing this manually. Because by doing that, by probing the environment, we'll even be able to leverage reflections on the walls to get higher signal power than we would if we just pointing to whatever thought would be best. And we didn't stop there, right? We started playing around with the flexibility of the initial access procedure. For example, shortening the time we stay, transmitting control frames gives us more throughput for the payload, and vice versa, which allows you to tailor your initial access to your own needs. You may sacrifice accuracy to increase the throughput if you so want. But I know this is still not finished, it's still work in progress. A few more things we would try to accomplish in the future. For example, replace the synchronous message passing by something else. While they work, they're asynchronous, and this is a problem for this kind of strict control schemes. And we also want to include some sort of mux or selector to change between payload and control frames during runtime that we don't really know how to do. So if you have any suggestions how to accomplish that, or if you're interested, please don't hesitate reaching out to me. And if you want to use all this, is all available open source on our repository, but you probably would need a couple of mmWave frontends to really use it. But luckily, we also have an open testbed open for remote experimentation. So if you're interested, please reach out.
Thank you. All right. While we have time for one question, next speaker may already come up and prepare. So are there questions? No? Oh, all right.
So, have you looked into like any of the 802.11 protocols that are involved with beamforming?
Sorry, sir,
Have
can
you
you
looked
repeat?
into any of the 802.11? I guess there's AD and AY
Uh,
that have.
No, we didn't really look into Wi-Fi related standards because like a whole motivation for this was actually targeting 5G and 6G systems, so we can't really talk say much about 802.11.